Hello students, today we will be studying proportional counters and Geiger-Müller counter or GM counter. First is proportional counter. When a particle of low specific ionization passes through an ionization chamber, the pulses produced is too small to detect. So we have to amplify those signals or those ionized charged particles of the ions. We have to amplify them. One way of amplifying the signals obtained from a gas field detector is to increase the electric field so that the electron gains enough energy between collisions with gas atoms to cause further ionization. Okay, we can increase the electric field and hence the electrons gain energy and causes further ionization. In such a case, the electrons produce further ionization and a rapid amplification of the original cascade occurs in what is called as a Townsend avalanche. That is called a Townsend avalanche. It should be noted that the size of the output signal is proportional to the number of ions formed by the primary ionization process. Such a chamber is called a proportional counter. So this is a figure. It consists of a cylindrical gas-filled tube. This is a cylindrical gas-filled tube. It has a radius of B. It acts as a cathode with a central thin wire. This is a central thin wire which has a small radius of radius A. It serves as an anode, and this wire is insulated from the tube. The central wire is positive with respect to the tube, which serves as the collecting electron, and this collecting electron is connected to an amplifier where we detect the number of pulses or the current, ionized current. This is connected to a pulse amplifier. So this is the structure of proportional counter. Next is Geiger-Müller counter or GM counter. This is in effect an improvement for the ionization chamber. Okay, the principle of this instrument is the fact that the ions created by the entry of an elementary particle moves in an intense electric field with such a high speed that ionization by collision results. So this results in ionization by collision. This causes a pulse of current which is used to record the incidence of ionizing particle. Okay, this pulse of current is used to record the incidence of ionizing particle. In GM counter, this pulse is independent of the number of ions produced initially, while in the proportional counter, the amplitude of the pulse is proportional to the number of ions produced initially. So this is the difference between GM counter and the proportional counter. GM counter pulse is independent of the number of ions produced initially, while in the proportional counter it is dependent on the number of ions produced initially. So these are the two most common forms of geometries of GM counter. The first one is this. Let us see the figure A. It consists of a copper cathode. This is a copper cathode. This is the copper cathode with a thin axial tungsten wire. This is the thin axial tungsten wire which serves as the anode. This whole thing is supported inside a cylindrical gas envelope. The ionizing particles enters the counter through its glass walls. This is the first arrangement. You can see cathode, anode and incident glass walls. And the second type is with an end window. This is the thin end window counter. This modification is useful for less penetrating particles. The window is generally made of thin mica sheets. The anode is a tungsten wire and the cathode is a graphite coating. Here too, this is another different design. This is a thin window. This is the anode, and this is the cylindrical copper cap, not copper, thin carbon coating serves as the cathode. These are the two different geometries of Geiger-Müller counter.